Dear esteemed viewers, today we are going to be having physics. Under our physics class, we are going to be treating heat transfer. Before I proceed, I will be using this question to explain the topic. But before proceeding, let me quickly define what heat transfer is and the heat specific heat capacity. Heat transfer is defined as the exchange of heat energy between materials. The materials might be solid, it may be liquid, it may be a gas. Whenever a temperature difference exists between the materials. So, meaning that before heat transfer can occur between these materials, the one thing that is important is that there must be the existence of heat transfer, about the existence of the temperature difference or temperature gradients between the materials. For instance, on a very cold day, let's assume it's during Harmattan. You see, most of us we will not want to use cold water to bath. So you heat your water, for instance. So because you want to receive some warmth, you heat the water on the burner when the water is hot. You mix the same volume of the water. You mix it with another one which is cold water. So which will now it will moderate the particular the moderate the temperature of the water. So one thing that I want you to understand in that regard is that heat transfer has come into play. The hot water has transferred successfully the heat energy in heat to the cold water inside the bucket. So that is it, the closest example of heat transfer within our homes. Then coming to specific heat capacity. Specific heat capacity is defined as that amount of heat required to heat the amount of heat required to raise the temperature of 1 kilogram of a body by what? By just 1 degree Celsius. Let's assume this is my body. Under specific heat capacity, the whole of this body does not concern me. I'm only particular about just 1 kilogram of this body. What I'm now after is that the amount of heat, that particular amount of heat that are required to raise the temperature of 1 kilogram of this body by 1 degree Celsius. That is specific heat capacity. The word specific is referring to just 1 kilogram of that body. So the amount of heat required now raise that temperature, raise that mass, that 1 kilogram mass by 1 degree Celsius. Now let's go back to the calculation. Solution. So the question says, a given quantity of heat increases the temperature of 150 grams of water from 9 degrees Celsius to 50 degrees Celsius and increases the temperature of an equal volume of oil weighing 100 grams from 9 degrees Celsius to 25 degrees Celsius. The question now, the ratio of the specific heat capacity of oil to that of water is dash. So the question, let's have, for instance, you have two two container. One of them contains water, the other one contains oil. So this one contains water, this one contains oil. Let's have this whole. This is oil. This is a H2O, for instance. So the heat energy received by this is the same amount of heat that will be the heat energy gained by this is the one that will be transferred to this man. Now we using the formula heat loss is equal to heat gain. We have m due to water, specific capacity of water, change in temperature due to water is equal to mass of oil, specific capacity of oil, and change in temperature of that oil. So the mass of water from the question, we're told to be 150 grams multiplied by the specific heat capacity, change in temperature, that is the temperature change from 15 to 9 degrees Celsius is equal to, so then for that of the oil, the mass of oil is 100 multiplied by the specific heat capacity of oil multiplied by the change in temperature of oil. That one change from 25 to 9 degrees Celsius. Now we move 150 multiplied by specific capacity of water multiplied by 15 minus 9. 15 minus 9 will always give us 6. Give us 6. You do it very well, it gives you 6. Then this is 100. We're coming to this side, we have 100 multiplied by specific capacity of oil multiplied by 25 minus 9. 25 minus 9, so we'll always give you, if you do it very well, give you 16. Now 150 multiplied by 6, that will give you 900 multiplied by, so you say we have 900, that is CW is equal to 100 times these are 1600, then C capacity of oil. Then now here you must be very careful. Look at the question. The question is asking you the ratio of the specific heat capacity of oil to that of water, of oil to that of water, not of water to that of oil. So as a result, it means oil must be on top, while water, that of water, specific capacity of water must be below. So now, following the arrangement we have here, you just divide both sides by that of water. Divide both sides by CW. We have 900 CW over CW is equal to 100. That's equal to 1600 C over CW. This one cancel each other. Then we have you transfer this one to this side, you have CO over CW is equal to 1600 divided by so you have 900. 900 will be here. You transfer 1600 to this place. You have 900 of 1600. Is 0 cancel 0, and at the end of the day we have 9 over 16. Coming to this side and making use of your long division method, we have 16. This will be 16. 16 will be outside and 9 will be inside the house. 16 in 9, 0 point. Then we'll put 0 here. 16 in 9 will give us 5. This will give us 5. So 16 multiplied by 5. 6 times 5, 30. Then we have 3. 5 times 1 plus 5, that will be 8. You subtract, you have 10. 16 in 10 is impossible. In 100, so this will give you 6. You put 6 here. Now 16 times 6, that will be 96. Subtract again, that will give you 4. In 4, 16 in 4 will give you 2. This times this will be 32. Subtract, this will give you 8. 8, that is 80. 16 in 80 now will give you 5. But your answers are left in 2 decimal places. 2 decimal places. And as a result, we have so the answer is equal to 4.56 to 2 decimal places. And this is the answer. So this one will be for those some of us that are preparing for post-UTME, this is for you. Preparing for NECO, WAEC, this is for you. Entrance exam, the nursing schools, and most of all these monotechnics or even the other institutions, this is for you. I remain your guy, your tutor, Comrade Alani. See you next time.